This video is going to cover the topic of using the distributive property. Be sure the date and topic are at the top of your page. The essential question for this video is how do we distribute values to make equivalent expressions? Since we're talking about making equivalent expressions, we should start by trying to decide what equivalent expressions are. And remember, an expression is something like x plus x plus x plus 9, right? There's no equivalent or equals sign, but it's just expressing some values. An equivalent expression is just a second or third or fourth expression that has the same value as, for example, x plus x plus x plus 9. So if I want to write it in a different way, I'm going to think for a moment of another way to write it. And since I remember that there are 1, 2, 3 x's, I could take that and make that my coefficient and do 3 x's plus 9. These two are equivalent. Some expressions are written in a way that we actually haven't seen before, so we're going to kind of talk about that, and that is with parentheses. So you might see an expression written like something like this, and that means something very specific. That means that this value in the parentheses happens 4 times. I'll show that with our tape diagram model so you can get a sense of what I mean. You can see here in my model that I have 4 sections and each one is identical and they have a value represented with the term x plus 1, right? The expression x plus 1. And seeing it this way, I could think about how else I might write this expression, right? So it starts off like this, right? 4 groups of x plus 1. But now that I look at it, I can see, oh, well, there's 1, 2, 3, 4 x's. So I could do 1, 2, 3, 4 x's. And there's 1, 2, 3, 4 values added together. So I could just do plus 4, right? So these already are equivalent. But then I could go even further and say, well, if there's 4 x's, I could just write 4 x plus 4. All 3 of these are equivalent. They look different, but they are telling us the exact same information. Here's another one. I have 3, and then in parentheses, 2x plus 5. When I see that, I think to myself, oh, that means the expression 2x plus 5 repeats 3 times. And that, of course, means in my tape diagram model, right, I have 2x plus 5, another 2x plus 5, and a third 2x plus 5. And the expression 2x plus 5 3 times could be written in an equivalent way. I notice, I'm going to count by 2's here, I have 2 x's, and 2 more x's. 2, 4, 6, I have 6 x's, and I have plus 5 plus 5, plus 5. 5 plus 5 plus 5 means I am adding 15. So these two are equivalent. The math term for what we're doing is called distributing. When we're distributing, we're using the operation of multiplication to multiply the terms that are inside the parentheses by the values on the outside that will then create those equivalent expressions that we've been creating here. This is not just important so that we can create equivalent expressions. We also use this when we're trying to solve equations. When I have the equation 2 outside the parentheses of x plus 4 equivalent or equal to 26, it might take me a moment to figure out what x is, but if I distribute, I might be able to do it with a little bit more ease. And I'm going to use the hanger method for this one because I know so many of you have really liked and preferred the hanger method. All right, so in my hanger, I clearly know one side of this balance is 26. On the other side, I know that it has x and 4, but it actually has that 2 times. So I would need to do another x and another 4. When I look at it now, I can see really clearly that there are 2 x's and there's a total of 8, and that is equivalent to 26. Knowing that, I can start taking things off the hanger. So I'm going to go ahead and remove 4 and 4, so I'm going to remove 8 from this side, but that means I have to remove 8 from this side as well. So now I know these two x's that are left hanging are equivalent to 18, so I can replace this with 18. And then I know that these two x's are going to get split among the 18. So I'm going to divide these into two groups and divide that into two groups as well. And when I do that, I find out that x is equal to 9. And that might not have been as easy to do in its original form, but by creating that equivalent equation, we were able to solve more easily for x. And we can of course do this without models. You might be noticing some patterns already. I've listed the examples we did so far side by side with their equivalent expressions, and we're going to go to this second one first. And so you can probably guess that really what's happening is that you took your 3 and multiplied it by 2 to get 6 x's, and then you multiplied your 3 by 5 to make 15. And one thing here is that when we have an x without a coefficient, it's really an invisible coefficient of 1. So I'm going to stick that in there. And then from there I say, oh, well, 4 times 1 makes 4, so there's 4 x's, and 4 times 1 is 4. 2 times 1 is 2, so there are 2 x's, and 2 times 2 is 4. I'll do one more here. So this one, 8 times, in parentheses, 3x plus 5. I would do 8 times 3, and that is 24, so there are 24 x's. And then I would do 8 times 5, and I would say that there are 40, and I know that that's being added together. For your turn, you can do this whichever way makes the most sense to you right now, but I'd like you to distribute what you see here below to write an equivalent expression. And remember, the essential question was, how do we distribute values to make an equivalent expression? And I hope we've seen some examples of that, and that that's starting to click a little bit with you, but we will of course be practicing this more together, so bring any questions you have to class.